So I will just briefly introduce the workshop and then we can get into the presentations. Today we're going to present some of the results that we have from the COLLECTiEF project. It's a Horizon 2020 project that is working on making buildings more energy efficient and climate resilience through an energy management system based on collective intelligence. So we have some project representatives today, and they will give insights from our work, some of the results that we have achieved in the past 4 years, and some examples from our case study here in Italy. So we have Mohammad Reza Gay, he is our project coordinator. He's a senior scientist at the NTNU, Norwegian University of Science and Technology. Then we have Luigi Doriano, he is the CEO of Energy at Work, and he's leading the work for the implementation, the testing, and the small-scale demonstration in the project. Marco Pietroboni is from R2M, and he's leading the exploitation activities in the project. And then we have Stefano Cera, he's from TECOS, and he's representing here the team working with the pilot here in Milano. And I'm Gloria Bevilacqua, I'm from Gionardo, and I'm leading the communication and dissemination activities. And in the project, we have some activities related to stakeholder engagement and building user engagement, and I'm going to talk a little bit about it. So I can leave the floor to Reza, and he can introduce the project. Yeah, I'm not sure how. Can we just move to the presentation?
I think we have to close the file. We should sit here. This project introduction. Yeah. Yes. Yes. Please to go back. The pointer. Yeah, there is a pointer, but not obviously. Here is yes. But anyway.
Because it's a
pointer. Exactly. So hello everyone. Thanks for joining us today. So I will provide a brief overview about the project. So this project running for 4 years. Of course, we extended the project recently. We are 15 partners from 6 European countries, and we have 4 urban pilots in 4 countries. So here are our team. So we have 11 industries and 4 universities across Europe. And here are our experts, just in glance, and some of you are here. So here are our objectives. So in this project, we created the collective intelligence-based energy flexibility network. We also use the cost-effective component available in the market, and we tested the collective solution in 14 pilot buildings in 4 countries. Of course, more or less, we are at the end of project, meaning that we actually already developed several solutions. And at the end, actually, we want to also exploit our results and hopefully roll out to the market at the end of the project. So I would like to invite you to just watch this short video, just get more sense about the project. I don't know. You want to help? That's a video. Oh, something happened.
Sometimes it doesn't work in a presentation slideshow, so you have to show the original video from the.
You are the original. Yeah, exactly.
Maybe also on YouTube.
Yeah.
I heard it. I think it's easy because there is another video. It's interesting. It's very quick. The first one. Yeah. Here. You should just. Sorry. Yeah. No.
Sorry.
Yeah, so you almost actually understood what's about this project. So, but briefly, I can explain how it works. We have a two intelligence node, one cluster node and edge node. And in the cluster node actually communicate the flexibility needs with the edge node, which is in the building level, and at the same time learn about their response, and also actually cluster node communicate with the energy provider and supplier to also understand about the request for flexibility. Of course, this is depends on the like a weather condition or price signal and so on. At the building level, also the occupants or end users, based on their preference and their comfort and so on. Actually, our system learn from the pattern based on their response to the cluster side, and also based on the preference. I mean, for instance, the set point changes or in the reduce the speed of fan and so on. Gradually, based on machine learning method, the system learn, and based on that, send the request timely. So we have also dashboard. Dashboard provide to the end user the capability in order to communicate with the appliances inside the buildings and also with the grid side. There is another short video. This is very interesting to learn more about how it works. Yeah. So at the edge side, we have a several digital solution provided by the several partners, industry partners, like a sensor, which is the user-centric device. And of course, we use the some cost-effectiveness solution available in market, like a smart valve and a thermostat. And and also we use actually the data from the EMS and VAX. About the business model, of course, my colleague will go through it, but just quickly, I can just tell you who is our end customer. So from the cluster side, the owner of buildings or managers and aggregator, public housing and energy committees, they are our, who wants to actually, sell the flexibility, they are like our end customer. And of course, the end user who wants to control the devices inside the building. Also one like the solution about the energy management in the building level. Also, they are our possible end user. So as I said at the beginning of this presentation, we tested our solution in 14 pilots in 4 cities located in 4 countries. In Olesund, which is in Norway, and Grenoble in France, Nicosia in Cyprus, and Milano in Italy. So we have a different type of buildings, residential, non-residential. We have a living lab in Grenoble, G3 lab, and we have a residential building in Milano. And in Cypriot pilots, they are like an educational building. And what we promised at the beginning of project, and right now we are in this stage to do some impact assessment. We promise at least we upgrade the smartness level of the buildings 1 level and reach to the 16% average reduced primary energy use and up to €3 per square meter annual energy cost saving. And of course, in increasing the user satisfaction in around 15% and increase the demand flexibility up to 24%. And most of this will be based on the SRI, Smart Readiness Indicator. I will discuss it further details in the next presentation. So, as I said, we're supposed to finish the project by end of May this year, but because of some technical issue and some issue about the installation, and took a bit time, and that's why our impact assessment took much than what expected. But then we, applied for the extensions approved, so the project ongoing, and it will be finalized by end of March next year. So here are some example of the monitoring system installation in the Norwegian side. And here is the small scale demonstration in Grenoble, which is in Living Lab, G2 Lab. And it was 2 years ago. And here also is like a time scale of the largest scale demonstration. It's already done. So we are, as I said, in the impact assessment period. Here are the data analysis impact assessment procedure. So several colleagues and partners working on that. So we work on the thermal comfort and indoor air quality assessment, and also energy flexibility, energy efficiency, and climate resilience assessment. And about exploitations, we almost actually prepare the final draft of the exploitation strategy. Still, we are discussing about how we can actually roll out our solution at the end of project. And we also prepare like some e-learning content as ready to be used publicly. And of course, we disseminated all our solutions in different events, conferences with some other sister projects. And also we had two stakeholder workshops in each pilot country, and it was successful. And hopefully at the end we are able to reach out again to the stakeholders and provide the final solutions and the result to them. So that's it. Any question, any points?
We can also like keep the questions
Yeah.
at the end if you want. Thank you, Reza.
Yeah.
And I think we can leave the floor to Luigi
Yeah.
to explain a little bit about the
Yeah.
system architecture and the deployment.
Let me find the so. Okay. So thank you very much, guys. Let's try to go through technicalities so I can explain.
Actually, that's deactivated
Ah.
USB. So if you want, you can just remove USB.
Which one?
Yeah.
Okay. Okay, so very briefly, we are from Manager to Work, a company that is active on providing a digital solution on energy and industry. We work a lot on European projects, and we work mostly on smart buildings and IoT solution applied to energy management system and system integration. Let's start from the value proposition of the project. So we offer an interoperable and scalable system able to be integrated with the energy management system, a lightweight algorithms based on distributed architecture from cloud to edge. Thanks to the algorithm that they are based on reinforcement learning scheme, the system is, let's say, able to learn and improve over time. And also another value is about, as also seen in the video from the Reza presentation, on human in the loop system, so an opera-centric dashboard that we will see in a while. And here, the first architecture we realized in the project. So just it's nice to see that the overall collective system is composed by a 4 main layer. We have the application layer that is more related to the interface for different customer segments, like aggregator, energy communities, and also consumers. We have the cluster layer that is able to execute at the cluster level algorithms and send instruction at each specific edge node. So in the distributed layer. Then we have a distributed layer that is composed by several multiple edge nodes. Each one is able to manage one technical functionalities or one dwelling or one building system. Specialized. And next layer, and above, of course, there is the field layer that is connected through hardware devices that we have developed during the project. So specifically developed using open hardware system. The core of the solution is, of course, the algorithms that we have developed. That is technological reinforcement learning demand side management system. So this is distributed among cluster and edge nodes. So basically, the cluster node calculates, so if the overall vision and calculates the forecast from the electric loads, from the thermal loads, and send to the specific edge nodes the signal. And the edge nodes provide optimization locally. There are different kind of signal that can be sent by the from the cluster node by the edge nodes. Basically, if the signal is 0, the cluster node send directly the set point. Otherwise, there is a scale, and according to this scale, the edge node will apply some specific boundary condition and some specific, let's say, intensity of the request, and using a reinforcement learning approach. So starting from a random generated point and constantly improving over time. There are other factors that are influenced by the user preferences and selections, as we will see later on. So the edge node, trying to be quick here. So take the local condition from the sensor and take also input from the cluster and calculate and execute the algorithms locally. Everything is supported by secure authentication and verification mechanism, both at the edge node and at the cluster node. While the cluster node has as a role a multi-site coordination, forecast estimation, and orchestration among the edges. And it's also collects, let's say, the history of the energy data to perform a more accurate forecast of time and aggregate results in PCI. Communication is mostly between cluster and edge. Using protocol like MQTT or REST for commands. Here, a quick edge cluster view. So we don't have the pointer here, but starting from the devices, data are collected from the app core. That is a solution completely developed in COLLECTiEF, hardware software solution. And then the algorithms use instruction coming, so set point control coming from the cluster node and the data to apply the modification on the specific devices. Then the edge node pass from the cluster the measurement, the energy, and the cluster node use this information to, let's say, apply the forecast and to aggregate the data and to pass to the controller. This is a more detailed general view of this of the edge cluster system. I will say let's skip this part, otherwise we may have too much to say. There is also, as we have seen, the occupant-centric fusion sensor interface that is able to provide real-time monitoring of the energy and environmental parameters collected by another device that I forgot to mention. That is a sensor system that is another device that collects multiple variables, including air quality measures. And of course, everything is included in the sensor interface. This is protected because it's locally deployed on the edge, so the information will not go through the cluster node. On the cluster node will go only the relevant information able to make forecasts and to provide the aggregated performance on the energy. So all the information will be, let's say, completely applied at the cluster level. This is also good in terms of security and privacy. At the interface, anyway, we will see we have a different mode, the operational mode that is able to give to the user a freedom to select the kind of operational mode the algorithm should work. These are just some screenshots about the home view where we can see the data coming from the system. And this is related to, let's say, very easy control, user-friendly, as you can see, control system from the user that can select different modes of the algorithms, comfort, smart, and eco. Very quickly, Smart offer a balanced, fully automatic way of operation. Comfort will reduce the boundary of the comfort system in a more narrow ways and also according to the user settings. And Eco is fully unbalanced on the optimization, let's say. Then user, in case COLLECTiEF does not work properly, can also select manual to switch off the system and play with the controls that are integrated with building management system, because we are fully integrated with building management system as a solution. So as also technical offer, we go to also facility management and facility managers to offer an expansion of the system in terms of functionalities that now are not so extensively provided. Very quickly, deployment activities. So we can see on the right the sensor that is able to provide measurement of the spaces. Smart thermostats. We have also smart flags. The implementation activities were spread over time, a lot of times, let's say, and we first installed the sensory data, and through the gateway we acquired the data used to train system. Then we used the emulation on the Grenoble Lim Lab to refine the algorithms, to make a second version of the algorithms, and then we installed everything on the pilot. We had some, as I was mentioning, some also issues. Apart from COVID, but also policy restrictions on a pilot that let's say forced us to install several times the solutions. Everything is now deployed, as already said, and we are now in the benchmarking phase in order to check if what we have promised are in line with the real situation. Very quickly, just to show that we have integrated hardware system from third-party devices that can be found on the market, and we have deployed mostly the energy flexibility algorithms on the edges in France, in Italy, and we have integrated DMS in France and Cyprus, and also in Norway. As a lesson learned, we noticed some limitations on the application of the algorithm, because in the reality, when you go inside the houses of people, you see that you are not able to make everything as planned. So some calibration of the system and limitation has been performed during the project, and likely, for instance, you cannot control the appliances of people. They are not happy, basically. And we created a reverse proxies to have a secure data handling. And also, as I said, we reduced the scope for some specific pilots in respect to the technical limitation. And also, we noticed that by integrating data from building management system, there was a lot of noise on this data. So we've relied mostly on few data, but with high quality data on these few data sets and a few in terms of field data. And that's from my side. Thank you very much. I would say, considering the time, let's go.
Okay.
Thank you.
We can go with Stefano with the presentation about the pilot in Milano.
And then we're gonna have a question.
Yeah, we can have questions at the end if it's all right with all of you.
Du musst das am Rücken, dass du just read it.
Okay.
Yeah. No. Oh, yeah. Okay. Thank you. I would like to be the last today. Okay. Last today, but there will be Marco after me, and I'm from Teikos. Teikos is a building company based in Milan, and I'm quite an alien today because I think Teikos is the only building company in all the 3 days of sustainable places. And there is a second reason why I consider myself an alien. I'm a physicist and I'm working for a building company. This is not so common. And Teikos is a building company specialized in renovation of large condominium. This one is a picture of our work that is currently going in renovation of public buildings. This is school and conservation of building heritage. This is the Villa Reale di Monza, which is a very big buildings that has, I think, 200 years. And today I would like to talk about the deployment of the system, which is the brig, which is the brain of the edge node, which is the easiest part of the system to be deployed, and the environmental sensor. And maybe they are the less easiest part to deploy, the actuators, and in the Milan building pilot that are 3 towers. But I would like to be the last today because I want to be frank, because usually this kind of tasks are given to the not so smart participant in the consortium. It usually is a building company. Okay. But I know it's true, and but it's the right way to do, because usually building company like Teikos has a huge experience in dealing with people. And in this case, in Milan, we have entered private homes so many times, and this is not possible to do if you are not used to do that, to speak with people. And so, this is the Spencer, okay, and this is the list of parameters, and all the Spencer needs to run on the same Wi-Fi
wireless LAN. So we created a single Wi-Fi LAN, placing a lot, and when I say a lot, I mean really a lot of repeaters in the common areas. So this is the rig, the modem Wi-Fi router, and there is one for every tower. And then we have placed, I think, maybe a dozen repeater in each tower. And I explained them why. And this is maybe the biggest challenges of the deployment, to put this sensor into private homes. Because sensor is, the producers say to me that in your opinion, it's a piece of art. But maybe it could be very fitted in the right picture in front of a chocolated Santa Claus, but not on the left picture in a very polite living room. So it will be a challenge to find people that wanted to take a sensor and put them into your house. This is another big mistake we made, because we have to choose the smart thermostatic bulbs, and as sensor ran on Wi-Fi, we decided to choose thermostatic Wi-Fi bulbs. But something went really wrong, and we need to replace them all. And this was not good for the relationship with the user. In fact, on the left, you can see a thermostatic Wi-Fi bulb, and in the right, the thermostatic LoRaWAN with a gateway, because there was a large series of connection issues with Wi-Fi and with LoRaWAN 2. I say we do tasks that usually other people don't want to do. They are not so smart tasks, but even from the most stupid task, you can learn something. And now there is a couple of slides about the lesson learned. First of all, why we choose people living there? Because Teikos was already renovating their homes. And the lesson is you need to have already a relationship with user. Otherwise, it's not possible to keep running the project for 1, 2, 3 years. How many users? We choose 12 users, while we can choose only maybe 9, 10. But some users could leave the project, and they did it. Now, in fact, we have only 10 users. So the lesson, and you have to find all users you can find, surely more than you need. Because take note that someone in 3 years will left the project. The choice of sensor, it was our biggest mistake, because Wi-Fi didn't work due to the thickness and typology of the walls, especially in the lowest floor. So the lesson is we should have projected a small rehearsal that we did not. And in fact, we had to change all the thermobars. Census versus user, because too many visits maybe to check if the sensors are still running or the batteries or something else. Too many visits put a strain on user patience, and some user in fact left the project because of that. And so you have to think to optimize the number of site visits, because you have to enter private homes and you can do it when you want or when you need. The user engagement, I think, is still I think we have to fix it all except this one. The user engagement in a filling questionnaire is very low. It's not an issue in Milan, but it is an issue, I think, common for all the pilots. And the lesson is to find way to get questionnaire filled. We are trying in organizing a meeting to give user Christmas present, okay? And we have set up a WhatsApp group. We organize a private meeting with the user, and then I have meet individually each of the user and ask of each of them, please tell me what I can do to help you to fill the questionnaire. This is an issue that is, in my opinion, is very important and usually is not so considered, because people talk and it's a problem. I refer not to user of the project, but to people that are outside the project. Because every time I go to the pilot, I find someone outside the project asking me, when will you leave? Because they don't want to see this kind of sphere on repeaters in the common areas. And oh, sorry. It's time to say goodbye because my presentation is going to an end. But I want to stress you with this last slide, because thanks to collective project in Tecus, we have understood that already now, but more in the future, we have to face the problem of managing scarce and finite energy resources. For example, think about to design and build a condominium electric vehicle charging system when kilowatt are limited, which is that is a case that already is happening. In Tecos, we believe that only collective solution, just as the COLLECTiEF project, can solve this. So keep in touch. Here my now I have to go, and this is my information contact. And thank you.
Okay. Still, I don't know if there is any pressing question, but otherwise we can move on and then still collect the questions for later.
Yeah, if you could, real quick, because
Yeah, while I set it up. Yeah, absolutely.
It might be hard to come back to this slide. More like a remarks, okay, in terms like the user engagement. So I'm a researcher and I research on thermal comfort of the end user, so the people, and I work with students. I specialize in university buildings, and it's a remark because I work with them, so we have to know our people, because we technical people, we're like, okay, just spread the questionnaire and they're supposed to fill it out. It's gonna help. It doesn't go that way. We spread it for the first time. Okay, they do it out of like respect for us. The second time they get sick of it, and so I have to really think about it. What interests them? Scores for their students. So if I give them scores, like, hey, if you complete this away, 5 points for you, they could like have more motivation. And I had to buy them chocolates, just for them to fill out the survey. And it's a reality that we have to deal when working with people, the engagement.
If I can say something more, the most part of the users in Milan are old people, very old people. Some of them during the project die. And so I asked the partner if we could maybe set a price, money, and Amazon discount. I don't know, but they say no, this is not possible.
Because of EU Commission policy.
Our pilot in the Cyprus pilot is a university, so there are a lot of students, and they, if I remember when, in the questionnaire, they are quite good. Okay. But in Milan, we have private homes and people who you are asking to fill it are the same. So they have to fill it maybe today, tomorrow, the day after tomorrow, and they say why. So I think that the questionnaire should be made maybe in a different way, because I joined the project not at the start of the project, but after 1 year. So I find the things in this way, especially in the pilot of Milan, there was two. Oh my God! And but maybe this is another learning lesson for the future.
This is actually setting the stage very well for this presentation. I will briefly go through, because I was saying at the beginning, so we are leading the communication activities and we're also supporting the partners in the pilots with the user engagement. So Stefano presented the case of the Italian pilot specifically, and then Reza and Luigi in their introduction, they showed also the fact that we have other pilots in other countries, and of course, like we try different strategies depending on the type of buildings that we had and the type of users that we had. Okay. Yeah. Okay. So, as we were saying, of course, like a project like COLLECTiEF really needs user engagement aspect, because otherwise we can do all of the research in the world and we can deploy all of the algorithm and systems, but they need to be tested in real life and we need to get a feedback from them, especially because we have this big aspect of user satisfaction. So it's not just about the energy efficiency, but also we want to make buildings more comfortable for people. So we need to know what is working, what is not working for them, what they need, what is the status they start from, and how COLLECTiEF or like the system that we're developing is improving their status, their benefits, etc. So as we've shown, we have started from the very beginning to engage the pilot building users, and we wanted to have like a baseline of the perception they have and the comfort level they had in the buildings. We set up these questionnaires, so they are we have two types of questionnaires. One is this post-evaluation, post-occupancy evaluation, which should need to be filled quite frequently, so at least like once a day in theory. And now we have this satisfaction questionnaire that is more, let's say, maybe like once a month or once every other month. So it kind of like captures a more like long-term perspective. And this was supposed to be done before the deployment of the collective solution and then after, so that we could compare the different perception and how the new algorithm and the smart energy management would improve the occupancy feelings, let's say. To do so, we had to really like be very much involved with the building managers, with the teachers, for instance, in the schools in Norway, and the nurses in the elderly care facility in Norway, with the pilot users in Cyprus, where we have university buildings, and with the residents in Milano. And then in Grenoble was slightly different because it was this small scale lab. So we tested everything before we deployed it, and it was kind of like people involved in the project itself. So we used them as a sort of like baseline for that. As Stefan also was saying, we quite encountered some challenges, especially in the response rates that were very different depending on the pilots, but also depending on the period. So, for instance, in Norway, we had very high period of responses when schools were starting, and then they kind of like dropped down a little bit, and then we reminded them. So we had a new wave of responses, and then it's always kind of like you need to keep them engaged and keep reminding them that, of course, like this is not just a one-time thing, but it needs to be consistent. So we tried different strategies. We set up some materials that they could use for that. We had like QR code around in the building, so with posters, with roll-ups, with stickers, for instance, in the schools for the table of the kids. We had some video explainers where some of our researchers, they showed exactly how to fill out this questionnaire, which questions were really relevant for us. Also, we adjusted the survey, so we had iterations of it. We tested the different variation of the survey, also because we realized that, of course, not all of the questions were working well in all of the context. So, for instance, with kids, you have to have different type of questions that you have with adults, or like in nurses, with elderly care structure, we needed to kind of like have questions that the nurses could fill out also for the patients. So we try to adjust and translate also in local languages so that we could make it easier for everyone to understand the questions and reply in the most useful way for all of us, so they would give us the more detailed feedback. We had also a lot of face-to-face meetings in each of the pilots. Again, as Stefano was saying, for instance, in Milano, it was a bit trickier because you need to think about the fact that you're going into their houses. So it's a bit of like, this invasion of privacy type of issue. So we needed to be a bit more careful, and we needed to kind of like think about some setups where we could make it more engaging for them to meet us. So as Stefano was saying, we kind of like organized something around Christmas time. So it was a bit of let's meet, let's conclude the year, let's give you some updates, let's celebrate Christmas together. In Norway, where we have a lot of different pilots and very different type of buildings, the local team goes to each building on a running level, and then they always meet with the teachers, and then the teachers are not always the same, the nurses are not always the same. Same with Cyprus, so the offices and the classrooms always rotate. So every time the new team comes in, our team goes in and introduces the project and kind of like explains how we would need to keep involving the people, because it's not necessarily related to the people in the room, but it's the room itself that we need to monitor. Okay. Okay, so as I was saying, we had some tailored strategies, also depending on the focus of each pilot. So as I was saying, in Grenoble, we had mostly researchers, so they were mostly interested in testing the algorithms and understanding how the questionnaire worked. So for them, it was mostly a matter of sending reminders so that they would just fill it out and be engaged. In Olesund, we wanted to understand how the system worked for different type of buildings and different type of users. So as I was saying, one-to-one meetings were really important. And in Milano, we explained, and in Cyprus also, they had more of a focus on the user interaction part. So they had some workshops related to that. They really were in charge of developing these user interface dashboards. So they focused a lot of work on that, and they collected a lot of feedback from the students, the researchers, the colleagues to help in that aspect. And then we also had stakeholder workshops. So Marco will present our business model and exploitation plan, but this is also an important part because we're developing all of this system, and then we're thinking about the long-term impact and the long-term use. So we have engaged with stakeholders locally in the pilot sites and then also at the European level to understand the needs, to understand the potential use of the system outside of the project itself. And here again, we had some tailored approaches based on the type of stakeholders that we engage with. And all together, I think we kind of mostly focused in Milano, in Olesund, on the exploitation part and the local adaptability and uptake of the solution. And in Cyprus, for instance, it was mostly focused on the public engagement. So the researchers had some workshops during the European Research Night where they involved, on the one hand, students and also children, and on the other hand, some more business-related stakeholders. As I was saying, we have developed the dashboard that Luigi also presented before, and this is where we kind of want to make the long-term engagement stick, because at some point all of the questionnaires are going to end and the data collection is going to end, and this is where we will keep engaging with the users also after the end of the project. This is how in our idea is how everything will be kept managed. And we have different type of user profiles. So for the building users, for the building managers, so everyone sees what they need to see, and they have an overview of the energy performance of the building, of the comfort level, and they can still fill out a schedule for the appliances, the heating, and all of that. So for now, we have different operation mode, but then eventually we only want to have this smart operation mode so that once the algorithm have been trained and they understand the user preferences, they can automatically adapt, so there will not be a manual mode anymore. That's kind of the goal. So everything will be managed by the algorithm themselves. And finally, we also have these education materials. So that's another side of the business, the user engagement activities, where we want to also educate them on the need for such a system, the benefit of such a system, and we have four main modules that we have been developing. So one is more of a generic overview of the energy efficiency and the EU policy frameworks. So really to set the stage of why is it important to have more energy efficient building, what is the EU doing, what are the frameworks, etc. And then we will go through more specific modules related to collective systems. So we have guidance on how to use the system. We have an overview of the benefits, and then we have an overview of the collective methodology, which is what as I was explaining at the beginning. Yeah, and this is it from my part. Again, if there is any question, otherwise we go to the last presentation and then we go to the questions altogether. Okay, we go with Marco and then, okay. Okay, then Marco will go with the business model and then we go with Reza for the SRI assessment.
I will keep it very quick, so we can discuss further.
Okay, yeah. In the meantime, if there is any question addressed to Luigi, because he will need to go before the end of it, unfortunately. So if you have any questions, I think there was something maybe that anyone wants to go on his presentation. Feel free.
Luigi, do you want to know?
I need to go in the meantime.
So maybe, okay.
Okay.
Thank you. So, yes, I'm Marco from R2M, from the COLLECTiEF Consortium. And let's say during our work during this year, putting together the technical development, the one that Luigi presented, and the overall strategy that Reza presented, and the real life situation and the deployment on the field, we develop some consideration about exploitation in the market of these solutions, so of the COLLECTiEF system, let's say. We identify this overall value proposition for this kind of control system, and all these points that can be typical value proposition point for a control system are particularly to be considered in this case for add control to legacy equipment, so to existing system, like we are doing in the project. We are moving in this market landscape, so between the energy grids, electricity energy grids, and thermal energy grids, district heating grids, for example, and the end users. In this landscape, we know that there are some needs for flexibility. For example, regarding balancing consumption and production in this kind of grids, or optimizing the self consumption from the renewable energy on site. In some of these cases, these needs are also related to obligations or to incentives in order to have flexibility and to boost the flexibility. We identify this product for the COLLECTiEF system that is an energy management system based on collective intelligence, and it is as much as possible interoperable and scalable. In the language of exploitation, we call this a minimal viable product. Let's say is the simple version of the product we developed. Thank you.
Sorry, guys.
And we identify the chance to further adopt or to commercialize these kind of systems both like as algorithms in itself, maybe to be implemented in existing BMS, or like a control system, like a, let's say, box, a device that can be added with existing BMS or existing system like Telmovals to improve the automatic control, or as a service to be delivered as a monitoring and optimization service. Here we define a map for the exploitation of this kind of system. And we identified, let's say, some priority path for exploitation. For example, about the target buildings. So we identified as priority buildings or more easy buildings where we can apply this kind of solutions. The buildings like offices or schools or tertiary buildings. Before we say that is very different because likely also the relationship between the provider and the people change. For example, in the case of Teikos here in Milano, the relation is among a provider and the customer, but now the customer is a volunteer because they accepted to participate to the demonstration phase of the research project. Maybe in the case of educational building, there is a relation between a professor, a teacher, a researcher, and the students. And similarly, in an office building, a commercial building, there could be a relation of, let's say, between an employee and responsible people that ask to follow some policies. So we identify, for example, office building or more collective building as more promising kind of buildings to adopt these kind of solutions. Also to avoid some constraints in structure. For example, to have the stairs core with concrete material and have a very poor signal between the elements. And then you can find more detail in that map. Then we identify also some possible trends where this kind of solutions, and in particular the collective solution, can be used. For example, in Italy, the trends of local energy communities can be an interesting opportunity because we can help to maximize the self-consumption of the energy produced by the on-site system. And so the functionality of COLLECTiEF can help in this way. But also some services related to the energy management of existing buildings can be make a profit to this kind of solution. Then we develop an analysis, a review of existing and innovative business and pricing models for smart building and with particularly attention of energy flexibility. We collect and we present this analysis in this scientific paper, thanks to the work performed in COLLECTiEF. In this paper, you can find a review of existing and innovative business models, mainly related to energy flexibility in buildings. And we review the business models according to different criteria. For example, the temporary granularity of the analysis that the calculation method related to the business model adopt, or the energy vector that is involved in the business model, or the type of the customers. So if you want, we can go deeper, or you can see in the paper. Yeah, and this is all. I give the floor to This is the final presentation of this session. So since we are behind the schedule, I just briefly explain about the recent result of the smartness readiness assessment of the different pilots. But yeah, firstly, let me give you very quick overview about the smart building. What's that? So the terminology actually of smart building started from 1988. So defines intelligence building as a those that integrate multiple systems for efficient resource management and occupants performance. Later on, actually, the human-centric approach also added to this, and emphasizing the importance of addressing the human needs. And of course, the definition, it was based on the digitalization technology available in that time, but nowadays we are actually discussing about the data-driven smart buildings by based on the use of the digital technology for optimize the energy use and indoor environment quality and also occupancy experience. And recently also we had a smart readiness indicator as a very accurate tools in order to assess the smartness level of the buildings. So I will go through it later. So a smart readiness for the building is ability to leverage its internal system and limitations to support the smart technologies. So we want to measure how well a building can optimize its own capabilities, focusing on the improving efficiency, adaptability, and also grid interaction within the building inherent constraints. And of course, the smartness is the comparison between the different buildings, how they actually can use this digitalization approach in order to, contribute to the energy efficiency and energy saving. And that's one comparison assessment to assess what's the level of the smartness of different buildings. That's why the smart readiness indicator could be very good tools for it. So the smart readiness indicator have three key functionalities as energy saving and operation, response to user needs, and response to the needs of the grid. The latter one actually is a recent approach, and there are lots of research ongoing on the latter one, because the first two, as I told you, it was for many years actually discussing, and there were some solution for it. And there are also 7 impact, including energy saving, maintenance, and fault prediction, comfort, convenient, information to the occupants, and health and well-being, and also energy flexibility and storage, which is the target of the COLLECTiEF project. And we should also target 9 technical domains, including the heating and domestic hot water, cooling, ventilation, lighting and electricity, electric vehicles, and dynamic envelope, and monitoring and control. So we all actually more or less explained about our pilots. I don't want to go through it much, but here I just wanted to show you some result of the Norwegian pilots, just about use cases. So in Norway, we have several non-residential buildings, including this belongs to the municipality of the Ålesund, located in the western part of the Norway, including the health facility and the healthcare, and also schools, several schools and sports centers. And for today, I just focus on the Eidet Omsorg Center in Norwegian, and the name is Eidet Healthcare Center. This is very, let's say, one of the smartest building in Ålesund, and it's around 7,000 square meter with the 4 floors, And you can find several solutions like energy systems, like heat pumps and solar collectors, PV systems, and decentral heating, and also EV. So in order to evaluate the smartness level of this building, we use the version 4.4 of the SRI methodology, and we consider the service Catholic E. And then based on the BMS data, we just evaluated the class of the building before applying the solution of the collective. So we gave the several weight. The 0 means is none smartness, and 4 is the maximum smartness level, and it's based on the available like a domain, as I explained to you, and also based on the how they can contribute to this. Of course, we consider mostly on the flexibility because the topic of the collective is about the flexibility, so we wanted to increase the flexibility in the building. So here also we provided the score based on the, I mean, this current SRI means that actually before applying the solution and expected SRI after applying. Still, we are working because the project is not ended, and we are actually also trying to also at the same time do the impact assessment and of course the SRI assessment. But as you see here, based on the first interaction, we could actually one level make a building smarter. So before applying the collective solution, the class was E. Just for information, we have an A to G, and the A is like a smarter and maximum smartness level, and also G is the minimum. So you see actually here we increased at least one level of the smartness as promised in our project. So here are some results based on the impact. So you see here we have energy flexibility, increasing the energy flexibility, convenient and maintenance and information to occupants. And about the domain, we also increase the heating and electricity and monitoring and control. So that was the main topic of the what we done so far. This is like a general overview of the 7 buildings. I don't want to go through it, but just for information, the IDET Umsuk Center is the B1, and it was actually, good because the building was smart enough at the beginning of project. That's why actually we couldn't really increase it. But in some other building like a B2, which is the sport center, it was not much smart. So after applying, we see a lot of good performance of our solution. As I said, still we are working, and hopefully at the end of project we can have a better result about the SRI application. Yeah, that's it. If you have any question or any comments.
Well,
Yeah, sure.
After,
Yeah.
No, it's just more like a discussion because it's really interesting to me. I don't know, just to me.
Oh, you're
Like I said earlier, I'm a researcher in thermal comfort and energy efficiency. So I understand the on the side of energy efficiency, but at the same time compromise on thermal comfort. And I do research on university, so students. Well, I have a question because I work so much with the end users. That means students. And in the case of in Norway, but in France, in education buildings, students do not have access to anything, even the door, even the keys to the door, let alone a control. The thermostat, they do not have control on it. So it's the centralized, it's the technical person who controls everything, right? Of course, right now we're not implementing the smartest system, but still we have a control system and centralized, right? The thing is, the temperature, we also have to install sensors in order to measure everything that you mentioned. everything that comes up calculated, they are sitting in the comfort zone in the system, showing, visualizing, perfect, great. But when I work with students and I do the post-occupancy surveys, that's another story. But the reality is that not many of them are so satisfied with the current temperature given, So the way that I've evaluated, I use many metrics. One of them is the preference metric. So I asked them, what sort of temperature do you prefer? Do you prefer it higher or lower? And the response given that if they could, they would make it like higher temperature. So if they have access to thermostat, they would. The problem is there are so many students in each classroom. My question is, because you've shown the way that the COLLECTiEF doing, like the preference, I noted like coolers, what's that? The select mode that you prefer, the user preference.
Dashboard.
I wonder, could you elaborate a little bit more? How does it really work exactly, and how do you implement it in the public building? Because everybody's gonna click, I want it higher, I want it lower. So at the end, what's the decision?
Yeah.
Yeah.
So as I said in one of our presentation, I think at the beginning I said it's based on the reinforcement learning and machine learning. So this data we gather from the end users. Our system learn automatically based on the pattern. So every time they respond, we learn actually in different climate condition, different season. We learn actually what's optimum preference for them. So it's not for, always. So maybe during 6 months, we gather data. After that, it's automatically learned and the pattern actually automatically uh, integrated. And at the end, actually, the decision automatically happen. So it's just for like a couple of time. Maybe 6 months, not more than 6 months. So at this stage, we just need the data because without data, we cannot really train our model. It's based on machine learning, reinforcement learning, and afterward, actually, we don't need really any additional input from the end user. Everything will be automatically. Of course, the type of building will be changed. I don't know if, for instance, the students in the first class go to the in other class, or maybe their preference will be changed. Then we should actually repeat it. Yeah.
Okay, but just to get a little bit deeper, is it within a 1 hour? How many times it's clicked onto?
I think the
How do you measure like?
during
The POE, yes. Then on the dashboard, now they can theoretically, when we deploy the dashboard and we give them access, theoretically they could change at any time, multiple times a day. But then once this testing period is done, they will not have a manual mode anymore. Because as Teresa was saying, it's machine learning, so it knows that this manual mode will not be available. So then they cannot really change so much. It's going to be like automatically based on their preference that the algorithm learned, and I think it's also like integrating the demand side overall. So what is the energy demand from all of the building in the cluster, etc. And it's going to make like a balance between what the building user want and what the energy side can deliver, basically. But then, for instance, like in a classroom, everyone has access to the POE, but only the teacher would have access to the dashboard. So it's not like every student, or like, in the elderly care system is the nurses that do the POE, but then is the building manager that has access to the dashboard. Otherwise, of course, every moment that someone could go and undo what the other person did, which kind of like defeats the purpose of it.
So from a perspective of researcher, I think this is just an open session, open question. It doesn't have to be answered right away. I'm just saying, because at the end of the day, for a building, for example, if it's a school building, then the most important factor is students. It's their productivity, doing tests, studying. If they're not comfortable, okay, it's the building manager who controls everything, just like you said earlier, it's teacher. But the percentage of teacher in a building, of a school building, students are more. So who's comfortable, whose comfort is it? It's an open question. This will be more improved, of course, but it's a very interesting session to me.
The main, actually, objective of project is exactly automatically we can set up everything. So of course, it's set point of the temperature also is part of it. That's why we have to learn from the end users. I mean, it can be elderly or students. Then based on their preference, we are able to set up everything. And of course, at the same time, this is important for energy flexibility because as I said, we want to also send the response. I mean, the end user will send this response to, I mean, supplier in another way. The supplier understand, okay, in which period of time or which time they should actually send a request for flexibility. And the flexibility means, for instance, they can just reduce the speed of the fan if it's in summer, or reduce the temperature, just for a while, or other action they can actually, or just maybe pause the, I don't know, the washing machine, whatever, and then it's providing flexibility to grid in order to just reduce any problem in the grid stability, and of course, if they are able to, provide the energy to, for instance, the elderly in the heat condition, for instance. Yeah.
Thank you.
You're welcome. I think you had a question.
Yeah. I was surprised when you showed, if you go back, I think 1, 2, no, more, or back. Yeah, no. When you showed that there was a little decrease in SRI in building components. I wonder why.
In IDET?
Yeah. Go forward.
Maybe forward, yeah. I think this was the main.
I think there is a slide. Okay. Score. I read the score building category. Score decrease slightly. Out possible.
Which of them?
This one. Why?
Yeah, that's about the comparison between the, because here we also did some analysis based on the data-driven model, because we even, the SRI is not sufficient itself. Of course, this is not the topic of today, but we did some evaluation in order to increase the accuracy of SRI, and it's based on the power needs and based on, of course, energy flexibility, and we published one paper about that. So here showing actually the comparison between the conventional method for the SRI evaluation and after applying the our solution. So it's based on data-driven model. So it's just comparison between that one. So it's not only about the SRI evaluation. But of course, this is related to project, and since we want to, provide the accurate assessment of the smartness level of the building, we did this. So if you are interested, yeah, there are a lot of research ongoing. Since you're a researcher, maybe it's interesting for you. There are a lot of ongoing activities about improving SRI accuracy, because the current SRI methodology is not sufficient in my point of view. So that's why you need to add some other methods like data-driven models, for instance, in order to.
I think in another session we had a discussion on SRI.
Yeah.
It was interesting as well in terms of the current SRI, the policy, and what could be done more. Interesting.
Any other question, point, comment? Or if not, I think Gloria, maybe you can conclude it, or I don't know.
Yes. Yeah, we're running a little bit behind schedule, so maybe we can wrap it up. You have our contacts, of course, like in the presentations and our website. So if anyone is interested in following up, or we also have some materials there if you want to grab it and check it. But thank you very much.
And by the way, Gloria, I forgot to say, we already published our data set. It's a very valuable data set. So if you are interested, you can just sign a very small NDA, and then we can just.
So the papers are free, so we can read the papers that I think that you shown, Marco.
Yes, open access.
Open source.
And the data could be found on the website.
I think if you go to the website, you can find the NDA, but it's published in Zenando.
Okay.
Zenando, if you know Zenando, it's the EU portal. Yeah. So, yeah. But just write to us if you're interested, and we can try to help you. Thanks for
Thank you so
joining
much.
us today.